Right. Good afternoon, everybody. I hope you all recorded your World Cup games. Unfortunately, I think it runs into this class, doesn't it? The France-Spain game, possibly. Do I have that right? Oh, nobody in here cares? Okay. All right. Can online folks hear us? Just making sure. Hope they can. Oh, good. Thank you. All right. So we are having our last session together. How exciting for you all. So you know what happens on Thursday, right? We have our last exam 3. Woohoo! Let's see what else. So you all know that you can drop your lowest exam grade, correct? Okay, so I will be releasing your exam 2 grades later on this evening. So that will give you a chance to decide what you want to do. If you want to try to improve your grade, or if you're happy with your exam 1 and exam 2, then you should be good to go. What will happen also is, for instance, if you decide not to take exam 3, then your scrap paper will also be excused. So basically, it's your lowest exam grade and its associated scrap paper that will get dropped. So keep that in mind. You don't have to worry about. So if you decide not to take exam 3, you do not need to do anything. You literally just don't take it. Don't touch Canvas for any reason, for anything to do with exam 3. And you don't even need to put anything in the scrap paper. So if you don't take exam 3, don't feel like you need to submit blank pages for your scrap paper. Don't need to do that either. So just realize if you opt not to take it, you have no need to put anything into Canvas. Okay. Then next week, who knows what's happening next week? Yes.
Project.
Yeah, you get to finish up your group project. You'll be done with your exams, and then you'll get a chance to meet with your team one last time. And then you'll be turning in your projects next week. And then after that, you get to showcase all of your videos in Canvas, and everybody will be able to check out what you did. So be on the lookout for Canvas announcements and for instructions on what to do. So you will be turning in your projects, and then you will also be watching each other's presentations. So that is what is on deck for next week. So don't feel that all that effort is for naught, because we will be checking those out. Okay, let's see what we got. So go ahead and minimize some of these things, and we'll switch over. And today you have your next opportunity to earn some bonus points for your exam section of your grade. So the winning team will be winning bonus points. You will also find out this evening who won last round's bonus points. And today will be your next chance for that as well. So you don't want to miss that. So bonus points will be added to your exam section. So regardless if you take exam 3 or not, if your team won the exam 3 trivia bonus points, then it'll still count even if you don't take exam 3. So keep that in mind. All right. Hopefully that answers quite a bit of your questions about what is happening. And we're going to go ahead and get started here. So let me share my screen. Oh, I think we had a question pop up, possibly, maybe. Let's start. All right, we're on section 4.5. And I will make see. Okay. We've got some stuff to look at. So section 4.5, this was all about coordinates. Basis. So we've been learning quite a bit about different sets of vectors, I have to say, from our previous sections. So we were talking about spanning sets, and then we were looking at whether or not a set was literally independent or not. And then now we want to have the exciting adventure of figuring out, is a set S, is it a basis? We're describing a coordinate system. So I think we're all used to the coordinate system that we usually use for our different fields of science and mathematics, but you are not limited to that basis. You could actually manipulate basis if you so choose. And so we have to have a way for describing a basis that is going to define our coordinate system. So we are going to have to do with this section, we've got to ask ourselves, does this set S, does it span a vector space V? Who can remember what that means? If a set S spans V, what do we have to check? Anybody remember? Ringing a bell? Does anybody remember what are we checking for on that one? Yes.
Checking if they're linearly independent.
Okay, yeah, so that's one of the things we also have to check. We're going to define basis. But one of the things that we have to check, if S is a basis for describing a coordinate system, we have to check if S spans V. So what are we looking for? S spans V. Then we're going to get to what you said, because that's in there too. I write this. Does that ring any bells? If I write that equation now? Well, that means for any arbitrary vector B, it can be written as a linear combination of the other vectors, set S. You would have a consistent system. Hopefully that rings some bells there. So then our next thing that we have to also figure out is if whether or not S is a basis. And then you had it. What do we have to ask ourselves next?
Linearly independent.
Oh yeah. So is S linearly independent? And for that one, how would we check that? What would we be looking for on that one?
Isn't it pivot points?
Okay, so we're going to be, yeah, we have some interesting things that'll come up about pivot columns and pivot points, all that good stuff. Does anybody remember the test though for linear independence? Let's see what we have in the chat here.
Isn't it if the determinant is not equal to 0?
Ooh, yes, all that good stuff is in there. Yes, we're going to be checking for those determinants, right? But basically what we're looking for is if C1 V1 plus C2 V2 plus C3 V3, or if you happen to have more vectors, that's fine too. You're going to set that equal to 0, and you should get only what? Yes.
Trivial solution.
You got it. Only the trivial solution. And that's where, as our online spokesperson said, yes, you are going to be looking for the determinant. We look for stuff like that because why? What would that determinant equal 0 or not? What would that tell us? Why do we care about looking for that determinant? Yes.
Unless if the system is consistent.
Yeah, it's going to tell us all those equivalent statements, right? So if it does not equal 0, then we know those other equivalent statements where we have only the trivial solution. We know that we also that Ax equals B and B is consistent and there's unique solution B, unique answer to B for any one that you pick. So interestingly, these are going to be the two things that we're going to look for. So make sure that you are well versed in your theorem 2.3.8, but this is actually going to get updated because we're going to be adding more equivalent statements to that. But okay, so let's go ahead and what are we going to do today? We're going to be looking at, let's go ahead and we'll look at problem 2 for our coordinates and basis. So let's check this out. Let's see what our book says for that. So we're going to check it out. All right. It says, show the following set of vectors forms a basis for R3. And they have given us this set here, and they have told us that it is 3, 1, -4. They've told us the next one is 2, 5, and 6. They have told us the next one is 1, 4, and 8. Okay. So we have to do those two tests, right? We have to show one, that it spans R3. And then 2, we have to show that these vectors are linearly independent. And then we'd be able to say, yes, this forms a basis for R3. Okay. So what do we have to check for this stuff? All right, so if we go ahead and look for that, then we have to check, and then we have to go ahead and write all this out. So we've got C1 times our first vector, 3, 1, -4, plus C2, 2, 5, 6, plus C3, 1, 4, 8. What are we going to set that equal to? If they span R3, well, we have to be able to find a unique solution for B1, B2, B3, right? Any arbitrary vector B that we pick. Okay. Then, do you guys mind coming on the other side of the pole? I can't see you all. Over on the side.
But this is nice way that I can work my laptop.
Yeah, there's definitely other plugs for sure.
I just push the table.
So yeah, if you want to move the table up so I can see you. I can't tell if you're asking a question or. Okay, so then we have what? So that's going to be our first one, yes. And then we also have to show that C1 times all this same stuff.
Is he okay?
What now?
Is he okay?
Is who?
Can I, it's okay right here?
Yeah, right here's perfect. Yeah, I can see you. Perfect. And so for our second test, what do we have to set those equal to? That would be our homogeneous system here. So these would all have to equal 0, 0, 0. And we'd have to get only the trivial solution. So what are we solving for in these equations? In these tests? We want to go ahead and do. So we know these are two things that if we're going to show that these vectors form a basis for R3, we have to show that they span R3. We have to show that they're linear independent. And so that's encapsulated by these two equations. But how are we going to go about proving this from those two equations? Remember from our, let's see.
You need to use matrices so we can find whether or not the determinant of the matrix is equal to 0 or not.
You got it. Yes. So we're going to go ahead. We're going to translate these into our systems. And then we're also going to make use of our matrix. So if we were to translate the two of these into our linear systems, we would have 3C1 plus 2C2 plus 3C3 equals B1. And then we have 1C1 plus 5C2 plus 4C3 equals B2. And then we got negative 4C1 plus 6C2 plus 8C3 is going to equal our B3. Lo and behold, it's going to be super simple because of this is going to look very similar for our other thing that we need to show. So then we also have 3C1 plus 2C2 plus 3C3. This time over here is equal 0. That's going to equal 0. And then our third equation is also going to equal 0. So this would be equivalent to solving AX equals 0. This one would be equivalent to solving AX equals B. They both have this same coefficient matrix that we're going to make use of. And lo and behold, it's a 3 by 3. It's square, yes? So that's cool. So that means we get to make use of all those cool equivalent statements that we know so well by now. So we have for A equals what? We've got, let's see, let's look at our numbers. We got 3, 2, 3, 1, 5, 4, negative 4, 6, 8, right? All right, so now's where we're going to use our determinant to tell us what we need to know. So if we look at this matrix and we dig deep, so thinking back to our previous chapters, what might be the quickest way to figure out the determinant of this matrix? Yes, sir.
I noticed you put a 3 on the first row last value. I thought it was a 1.
Oh, yep, you're right. You're right. I got some typos in here, don't I?
Yeah,
Can I fix it?
like that piece connects.
Yes. Yes, I think I did. Let's see. 4, so 148, 148, and then 148 for C3. Okay, thank you for that. Got carried away with all my numbers. Okay, so what do you think, remembering back to our techniques for determinants? So don't forget about all of your chapter 2, right? It's going to come back to haunt you now. So if we have this 3 by 3 matrix, what might be one of the simplest ways to calculate the determinant? If you just look at this.
Arrow technique.
Yep. We like our arrow technique. We don't have any useful zeros. I don't know about you, but I might not feel like fooling around with my row operations, remembering what has negative sign in front of it or not. So you might want to go ahead and do your arrow technique. So don't forget that with the arrow technique, what do you have to do? You have to repeat your first 2 columns, right? So we have what? 3 times 5 times 8. What would be the next one? Yeah, so 2 times 4 times -4. And then we have 1 times 1 times 6. And then we have to subtract going back the other way. So we have 2 times 1 times 8 plus 3 times 4 times 6 plus 1 times 5 times -4. And who can tell me what that is? Who can go ahead and calculate that the fastest? See what we end up with here.
I believe it's 26. Sorry.
Yeah, good job. We got 120 minus 32 plus 6, then minus, we're at 16. 72 minus 20. And as you said, you get 26. So what does that tell us? That tells us very important information. It tells us our determinant of A does not equal 0. So we now know.
It's linearly independent.
You got it. It's linearly independent. What else do we know? Yes, sir.
The system only has the trivial solution.
Yeah, exactly. So that tells us it's linear independent, right? Because we only have the trivial solution for AX equals 0. And then what else do we know about this?
Space.
It spans R3.
Oh, yeah, it spans R3. That's another one. You were going to say something too?
That it's consistent for all B.
Yep. So that would tell us it spans R3, yes. So for AX equals B, it's consistent for any arbitrary B you might pick. You got a unique solution. So those two things, we have shown it's linearly independent. We have shown it spans R3. So we can conclude what? This is a basis for R3. Yay! Okay. So how about that? All right, let's see the next problem we're going to look at here. So did anybody have any questions about that one? Don't forget about your tests. Don't forget about everything you've ever learned. We will look at problem 12A. Let's check this one out. See what we got here. We've got 12A. All right. It says find the coordinates vector of W relative to basis S equals 1 for R2. Okay. And then they are telling us for part A that U1 equals 1, -1. They're telling us that U2 equals 1, 1. And they're telling us that W equals 1, 0. All right. Interesting. So they want the coordinates vector of W. All right. And they have the basis of U1, U2. So we know from this, if U1, U2 is a basis for R2, what should we know about W then? U1 and U2 form the basis.
W is like extra,
Huh?
it's linear dependent.
Interesting, yeah.
Oh, wait.
We say about W, what are we trying to calculate? We have a coordinate vector of W. What are they asking us to find? Yes, sir.
W can be formed by a linear combination of the bases.
Oh, good job. Yes. So we know that U1 and U2 are in the basis. That means that any other vector should be a linear combination of those. And W should be as well. So, okay. So what do we got? So that means that we have C1 times 1, -1, and this will be U1, plus C2 times U2. Yep. And that'll equal 1, 0, which is our W. So when they say the coordinate vector of W, you know, W here is a linear combination of U1, U2. What are we being asked to find? This question. Here we'll be going back into your definitions for this section. So we're going to be solving for, let's see if our online folks got it. Oh, yet. We're solving for C1, C2 here. And we're going to report that as, we're going to use our correct notation from this section. Then our coordinate vector for W relative to the basis S, it's asking us to find this vector C1, C2. We know how to do that, right? So how are we going to do that? Very similar to some of our other problems, right? Yeah. So we got to go ahead and create our system, right? So we've got 1 C1 plus 1 C2 equals, anybody can guess it? That first equation going to be? Yeah, 1. And then what do we have? We've got -1 C1 plus 1 C2. What's that one going to equal? 0. All right, if we're going to simply solve this, what will we do? Well, if you want to be official about it, you have your augmented matrix to figure out your solution for this.
Could we just subtract the equations though?
Or you can subtract one equation from the other. So at this point, it's a very simple matrix, so you probably don't even need to do it, but just in case you get a little bit more complicated one, you would translate that to your augmented matrix. And you'd go ahead and solve, right? So I'll let you decide which one's easier for you, but you should get to a matrix that looks like this. And this would be in reduced row echelon form. And what would this tell you? Well, hopefully you realize that this would tell you that C1 equals 1/2 and C2 also equals 1/2. So then you would go ahead and say that the coordinate vector of W relative to the basis S equals 1/2, 1/2. And so you'd be making use of this cool coordinate vector if for some reason you define your basis ways. You'd have a way to do that. So we didn't get to that application, but further chapters, you would be making use of this. So very cool thing to know how to calculate. All of it is reliant upon things you have already learned before. So, all right. Let's see, what are some other main points? So we know that section 4.5, we're really getting into it. Okay, so that was section 4.5. So I would hope with that section that you do know how to determine whether or not a set of vectors forms a basis for, a given vector space. Does anybody remember something that you might want to remember from some of these theorems? What's something that you might want to check for? Let's see if anybody gets it. What if, say if we go back to problem 12a, let's say I said that a set, oops, sorry. Let's go back to problem 2. Didn't go back far enough. Let's say that I gave you this set, and the one that the problem officially gave you was 3 vectors in there. What if I had given you an additional 4th vector in there?
Linear dependent. So you would have to remove one for a basis.
You would. Good job. So do remember, go look at some of these theorems. They have some interesting information. I'll be providing them to you on the exam, but like you astutely said, there's a theorem that says let S be a set of vectors v1, v2, all the way through vr. It's a set of vectors in Rn. If the number of vectors is greater than n, then S is linearly dependent. So you might have to remove a vector to find the one that forms the basis. All right, so interesting stuff. Always be noticing what they're giving you. Be looking at the number of vectors you have in sets. Be looking at what kind of vector space are they asking you about. Get that dimension. Okay. Let's see. So any questions about what we did there? All of this is stuff that you know how to do really, really well. And you're going to be bringing it back. Let's see. All right. Looks like Cody's got it. Yeah, he got C1, C2 equals 1/2. Yes. All right. So we're going to be looking at next our section 4.6. And that one, let me go ahead and the next section. 4.6. Okay. And we're going to be looking at some problem there. All right, so this was all about dimension. What is a dimension?
The number of basis vectors.
Exactly, the number of vectors in your basis. It's simple enough. So, can a vector space have more than one basis?
Oh, definitely.
Okay, so you are not limited to one basis for a vector space. You might have a lot. But what is the one thing they will all have in common?
They will span whatever space.
It's the name of the section. What So you can have a vector space, your vector space could have many different bases, but all those bases will have in common what?
Same number of vectors.
Same number of vectors, so their dimension, right? So cool stuff there. All right. We will go ahead and let us look at, we're looking at, I think, let's go ahead, which one though? I do two, probably. All right. This one says find basis or the solution space of the homogeneous system and find the dimension of the space. Okay, well, let's check out this. All right, and it says, here's our system here. We got 3x1 plus x2 plus x3 plus x4 equals 0. We have 5x1 negative x2 plus x3 minus x4 equals 0. All right, this is a homogeneous system because why?
Equals 0.
Yes, our equations there equal 0. Digging back to previous sections, what can you all immediately tell me about this system?
It's gonna have infinite solutions,
Oh, good job. Why?
more variables than equations, and they're both intersecting as the origin.
All right, awesome. So dig back from concepts you've already learned. You should immediately have some knowledge about this system. So as you say, since it will have infinitely many solutions, what does that tell us is involved?
I forgot the name of the variables, but you have to put it in like a general solution. So you need.
It's called parameters.
So we're going to be looking. All right, so we're going to be looking at some of that stuff. So good memories. All right. So we know from this particular system, we're going to go ahead and we're going to set up our augmented matrix. We have infinitely many solutions. It's, not quite as easy just to subtract one equation from the other. So we got, what's it, 3, 5, 1, negative 1, 1, 1, 0, 1, negative 1, 0. Let's see if I have all that correct. 1, 1, 1. Okay. All right. So we're going to have to go ahead and, ooh, that's nasty, isn't it? All right, fine. So I'm going to go ahead, divide my first equation by 3. Ooh, I don't like this one. This one has a lot of fractions. Okay. 1, 1, negative 1, 0. All right, so that got me my first leading 1. Okay, so then I think I'm going to do negative 5 times the first equation and add to the second. Oh boy. So then I get 1, 1/3, 1/3, 1/3 at the top. So negative 5 times 1 plus 5 is 0. Ooh, oh my goodness. We have negative 5/3. Was that minus 3/3? So what's that get me?
8/3.
Oh, okay, yes, -8/3. Whew. Next one, we get -5/3 minus, what is it? Oh, wait, plus 3/3. This one's gonna be different. So what do we get now?
2/3.
Yeah, okay. Whew. And then we got -8/3 again and 0. Fun, fun, fun. Okay. Well, oh boy. What do we think we want to do now?
Times by 3 on the bottom. Oh, no, wait. That's how I would do it.
Okay.
I would have done that, but
Yeah, you want to get rid of that nasty 3 on the bottom?
I would have
Okay.
done it to both, top and bottom.
But then that would make this a 3 again.
Yeah, and then I would have gotten the 0. That's how I want to put it.
So you can do this in definitely different ways. If you find there's a faster way for you to think about it, we can go ahead and we'll get stuff. You can definitely do this.
Just times 8 to the top.
All right. Then if you want to go ahead, then what would you do?
You gotta times it by 3 to the top as well. You're committed.
I'm committed. What would I now do? I could divide the bottom by 8 if I'm committed to my factions. You could have 0. What do you get? 1, 1/4, 1, 0. What do I have to get rid of next? So I have this leading one, I have this leading one. Now what do I gotta get rid of? What am I looking at next? Are we done with this matrix yet?
No.
Oh, we gotta get it into, don't forget, we gotta get to reduced row echelon form. So that means I'm gonna have to do what, the bottom row times -1/3 plus the top. So let's see, now I get a 0 in that spot. And got 0, 1/4, 1, 0. Ooh, oh my gosh. All right, so what does all this mean? So if we look at this, I'm going to go ahead and look at that first equation here. We've got what? x1 plus 1/4 x3 equals 0. So I can say that x1 equals -1/4 x3. Yeah. Then for this second equation here, what do we have? We have x2 plus 1/4 x3 plus x4 equals 0. So that's going to go ahead and lead me to x2 equals -1/4 x3 minus x4. What do I do now? Do with these types of systems? Yes.
You set x3 and x4 to, no, not x3. x2 and x4 to S and T. So that we can
X2 and
find
x4?
Yes.
Interesting. How do we know what to do? All right, so let's look at this, what we got for our resultant RREF. What are we looking at? We have leading ones here. So we have leading ones for which variables? For which ones? X1, X2, right?
Yeah.
So what are our free variables then?
For
Our free variables are gonna be x3 and x4. So which ones get assigned the parameter?
Ones without leading ones.
Yeah, so let's go ahead. We're gonna assign x3 equals s. We got x4 equals t. So our complete thing would be x1 equals -1/4 s. x2 is -1/4 s minus t. Then x3 equals s and x4 equals t. Now, did I answer the question of this problem? It says, find a basis for the solution space of the homogeneous linear system and find the dimension of that space. Okay, well, we're not quite there yet, right? So what do? All right, well, we know then that x1, x2, x3, x4, what we would do is, hopefully you remember from previous sections, but what you want to do is you want to pull out that parameter. So we're going to pull out s, and if we look at in the x1 component position, we'd have what? 1/4, right? And then for the x2 component position, we'd have another -1/4. Anybody guess what we'd have next for x3 component position? Yeah, we'd have 1, and then we'd have what? 0. Then we're going to do it again. We're going to pull out our t. And we get, hopefully you see we get 0. We get -1. We get 0 and 1. So that would help you to write your general solution to this particular homogeneous system. And so you could then go ahead and assign what other value you want to s and t for your parameters. And you would have a solution to that system. So what this means is that, can anybody guess what this means in terms of answering our question? So that means that our vectors, -1/4, -1/4, 1, 0, and 0, -1, 0, and 1, those are going to form what? The basis of the solution. So any other solutions are going to be some other multiple of those. All right, and what do we also know? Oh, we know the dimension is, how many vectors are in there? Dimension of 2. So, hint, hint, I might ask you a question like this on the exam. So, do they form, can you find a basis for the solution space? Can you find that dimension? So, does everybody see what we did here? Started off with our homogeneous solution. We went ahead, we converted it to an augmented matrix. We reduced it down to its reduced row echelon form. We went ahead and looked at our leading variables versus our free variables. Went ahead and made those assignments. Then we went ahead and pulled out our parameters. And then we were able to go ahead and form our basis and figure out what dimension. So by doing this problem, what can you kind of figure out? Something that you could say. Some things you would look for. So remember I had you look for the fact that immediately you knew, like you said, there was more variables than equations. So that told you.
This is a plane of solutions that is the null space, right?
That's what?
This is the null space, right? A plane of
No, this is the basis of the homogeneous system. Yeah, so we're gonna be looking at the basis, yeah.
It's 0.
Saying that,
So not the null space.
when we're talking about the null space, that would be referring back to A, and usually that's a square matrix. This is not quite the same. So this one, our matrix was not squared.
I wouldn't have realized it if I didn't read it, but it would be the relationship between the parameters and the leading ones, which is our known variables and our unknown.
Yeah. So that gives you hints to your dimension, right? And then how many different vectors you should have in that basis. So. Okay, let's see how we're doing. Okay. So be aware of with your section 4.6, you need to know how many vectors are in your basis. You might be asked to find the dimension. You might be asked to actually find the basis of the solution space. So be checking that stuff out. All right, let us go. We got sections. Right. Ooh, now we get into section 8. Okay, so you know that, before I into that, section 4.7, we are going to go ahead and skip. And so then we're going to go to section 4.8. So 4.7 will not be on the exam. Section 4.8 will. And that would be on row space. And we're also going to look at column space. Null space. Now, keep in mind, I'm only going to test you on the stuff that we cover in class. So, like, you're going to want to pay attention to the problems that we end up going over. And those are going to be the ones that I expect you to be pretty well versed in. I also, because I keep asking you probing questions, what can you tell me about your system? So be thinking about those things. Do you notice patterns? Are there different assumptions that you know you can make by looking at things? So you might have to explain something on the exam. Okay, so let's see what we got for 4.8. Next section here. Okay, so some important things to remember about our row space. So it kind of follows along with all the stuff that we've been talking about, right? So we're going to be looking at the row space of A. And you're going to want to, these are always going to be on your exam. So I'm not expecting you to memorize it, right? But you want to go ahead and know a couple things about these things. So this is going to be, your row space is going to be your subspace spanned by the O vectors of A. And so once again, now that you've made that observation, you want to think about, okay, you have your matrix in row echelon form. You're going to be looking for those rows with what? Leading ones. of our leading ones. All right. These are all going to come into play. And then for our column space of A, this is going to be a subspace. Expand by the column vectors of A. And the A columns corresponding to the row echelon matrix R columns. Once again, with leading ones. Gotta be looking for those ones. Right. So then we have our null space of A. And as you said before, it's going to be your solution space of a homogeneous system. AX equals 0. And so we might want to go ahead and solve a matrix for AX equals 0. An augmented matrix. All that cool stuff. So those are going to be the different spaces you're going to want to be aware of. So we're going to go ahead and take a look at our problem. And let's see, which one am I going to have you guys look at? So we are looking at four. Oh, fun. Oh, four. I think that's the one I'm going to over. Maybe it was. Actually, let's do what's a more interesting one. We'll do from the back. Actually, let's do 10 first to make sure we fit that one in first. That one's a little bit more important. Okay, so we're gonna look at problem 10A. Okay, so what does it tell us in problem 10A? It says find the basis for the null space and row space of A. And they've gone ahead and given us A here. And we've got this fun one that is 1, 2, -1, 4, 1, 3, 5, 3, 2, 2, 0, 2. Okay. So, oh boy. Whew. What do you think we got to do?
Vectors. Users.
So if we look at our different definitions here, got row space is spanned by the row vectors of A. Looking at a row echelon matrix R, the rows with the leading ones, null space, that's solution space of homogeneous system AX equals 0. So you want to go ahead and solve your matrix for AX equals 0. So what do you think we're going to do? This matrix, kind of figure these things out.
Linear combination. Right? Linear combination of the vectors from space.
Well, we can actually, if we don't have to even go that far, we can make use of our augmented matrix right here that we have here. And what we're really looking for is what? Do you think? What are we gonna want to do to it? Help us. You have to find the null space, basis for the null space, and the row space.
What if we could get it into like RAF form or something? And try to see if we have got like an independent system.
Okay. So yeah, I like it. Let's go ahead and reduce this baby and see what we get. See what this tells us. Okay. So we are going to go ahead and we are going to get this into reduced row echelon form here. Whew. Hopefully we won't have such rough fractions on this one. Let's hope not. Okay, so. All right, I'm going to add the first row to the third row. So 1, 4, 5, 2, 2, 1, 3, 0. Add the first row to the third row. What do I get? 0, 7. What do we get now? 7, and then 4. Okay. Now what? What do you think?
Times the 2 to the top and add to the second row.
Okay. See anything else? Okay. So we get 1, 4, 5, 2. We get 0, -7, -7, -4. So we got 0, 7, 7, 4. Interesting stuff is emerging here.
Was a perfect week.
Oh, okay. All right, so we've got a leading one here. Let's get rid of that -7. So we got 1, 4, 5, 2, 0. Oops, sorry, 0. We get 1, 1. And then we get ugly, but oh well. And then this one, we'll get 0, 1, 1. And this will be there. Okay. So this is my next leading one. All right. I'm going to go ahead and use my second row. Do 1 negative times the second row added to the third. So 1, 4, 5, 2, 0, 1, 1, 4, 7th, 0, 0. We get 0, 0. Ooh, what do I need to do now? So I've got a leading one here, I got a leading one here. What do I gotta do to finish this up?
Get that 4 out.
Yeah, we gotta get rid of that 4. So what are we gonna do? -4 times the second row added to the first. So what do we get? 1, 0. 1. Ooh, what's this last ugly fraction gonna be? Can you do quick math in their head? Was that -16, 7 plus 14, 7, -2, 7. Okay. Now what? Now we got 0, 1, 1, 4, 7, and then 0, 0, 0, 0. Ooh. Okay. What we do with that? Got a leading one here, a leading one there. So if we know anything about row space, a basis for the row space in your definition from this section, what do we know our basis for the row space is?
Vectors. Row 1 and row 2.
Got it. So we're going to be looking for those leading ones. So we've got in our set Got 1, 0, 1, -2/7. And then what's our other one here? We've got 0, 1, 1, 4/7. And so this would have a dimension of 2. Okay. So look for those leading ones. Now, when we're talking about null space, what do we have to do with that? Let's see, we got a question from online that says, will there be questions like number 12 or 16 from 4.6? We did together from 4.6, we did number 2. So you definitely want to make sure that you know how to do that. So I'm going to probably be sticking mostly to the problems that we cover in class for your exam. So focus on those first, for sure. So 4.6, what were they asking us? You said 12 or 16. No, I won't do that to you from 4.6. No, you don't need to do 12 or 16. Okay. Okay, so back to our null space. What do I do?
I think we should convert it. Yeah, it's equals.
Yeah, we have to remember that our null space is going to be what? Our solution space to going to be interesting about our null space. All right, let's go. I'll refresh your memories. I'll go ahead and read it to you. The solution space of the homogeneous system of equations ax equals 0, which is a subspace of Rn, is denoted null A. It's called the null space of A. So based on that, just shared with you about that definition. What do you think we should do? Have this matrix A, and so we know for the null space, we have to solve AX equals 0. We have to find that solution space, right? So we're going to go ahead and look at what we got for our reduced row echelon matrix here. And so we can see from our first line of our matrix, we can see that x1 plus x3 minus 2/7 x4 is going to equal what?
0.
0. All right. Then what do we got? We've got from our second row of our matrix, we've got, ooh, what's that one? x2 plus x3 plus 4/7 x4 equals 0. What do I know? What else do I know?
2 numbers.
Yeah, so we only have 2 leading ones. So we've got x1 and x2 are our leading variables. We know also that we have more variables than possible equations here. So we've got infinite solution. We know we've got some 3 variables here. So we've got x3 and x4 are going to be our free variables. So we're going to be doing something very similarly to what we did before. So we've got what? We've got x1 equals negative x3 plus 2/7 x4. Okay, then we have x2 equals negative x3 minus 4/7 x4. All right, well, we're gonna have to go ahead and once again, we're gonna assign our x3 to our parameter. x4 will make our t. Then I'm gonna rewrite then x1 as what? Negative, we say negative s
Yeah.
plus 2/7 t. And then that means x2 is going to equal negative s minus 4/7 t. All right, so now we got all of them. So what are we going to do?
Going
x1, x2, x3, or x4. Ooh, we got to go ahead and pull out our parameters, don't we? We've got s times what?
negative one.
We got -1 for x2. What's our next one? -1 for x3. We got 1, and then we got 0. Then we've got to pull out our t. And we've got, ooh, this one's a little bit messy, right? 2/7. Then we got negative 4/7. We got 0 and then 1. So what do we know? We know that -1, -1, 1, 0, and 2/7, -4/7, 0, 1 forms a basis for null space of A. Woohoo! All right. And if we wanted to even get even more into it, your dimension 2. Okay. Fun stuff. So I think that's a good place to go ahead and take a break. All right. So before we go to break really quick, does everybody see? Let me check the chat really quickly. Let's see. I think I answered Angelina's question. Tony was helping with our fixing. Good. I don't see what we covered 5.1. You know what, folks? I think we have to have breaking news.
What's the breaking news?
I think we're going to have our breaking news that we're not going to have chapter 5 on the exam 3. You all happy about that? Yeah, less stuff. So these problems just always take a little bit longer than you anticipate. So breaking news, tell everybody you know, we will not do chapter 5 on the exam. However, I do encourage you to check out section 5.1 on eigenvalues and eigenvectors. And
Wait, so the exam's gonna be based on one chapter?
yes, but we had several different sections in it, didn't we? We had
It was like 8.
a lot of sections. So it's pretty much equivalent to your other exams, which had similar number of sections. So these chapters are really in depth. There's so much stuff in them. You have to, and they keep building, right? You have to remember the stuff from the sections before.
So the exam be
So Cody, let me go ahead and I will answer you. So breaking news. Let's see, chapter 5 will not be on exam. Okay. And let's see what we got here. General, we will go ahead and break until 4 o'clock. All right, so we'll see you back then. We'll finish up and then you get your next trivia opportunity. So we will do it.
Get some type.
Yes.
That's.
Like you were trolling me.
All right, we are back. We're almost there, folks. We're almost there. Quickly. As big as it gets. All right, a few more points here. We are going to now look at section 4.9. And we're going to be focusing on rank nullity. And I want you to think about the matrix that we just did. So we looked at this matrix and we looked at those leading ones, okay? We knew from those leading ones what the dimension we had for our basis. Now, what we're going to be looking at now is what we are going to be looking at is rank. So that is, if you're going to look at this definition from your book, rank is going to be the common dimension. Does anybody know of what two spaces?
All column space or row space.
Yeah, so in this case, the keyword here is common dimension, right? These should have the same dimension. That's going to be your row space. Anybody guess the other one? But we'll have the same dimension. Hopefully you guessed it. Hopefully you guessed column space. Because if we were to go back and look at that matrix that we did before, we only have two leading ones, right? So that's only going to correspond to 2 rows and 2 columns. So they're going to have that same common dimension for their basis. And since they're a common dimension, that's your rank. And then they've decided to get all fancy, and they have decided to give the dimension of the null space yet another name. And they're going to call it the nullity. So if we didn't have enough terms. So that is going to be the dimension of the null space. Okay. And your key thing that you do need to remember here is that your rank of your matrix A plus the nullity of your matrix A, that is going to equal, does anybody know? I reviewed this section.
And
Yeah, what did N mean?
the number of variables.
Oh, so close. Get there, yes. Very closely related to that, depending on what matrix you're using, yes.
The number of columns.
Yes, that would be your number of columns. So if we look at the matrix that we did before, what is our rank? Look at this one here. It's 2. What was our nullity then? So if the rank plus the nullity has to equal n the number of columns, that would be 2.
Yeah.
And we found that out anyway because we went ahead and solved that system and we pulled out our parameters and we figured out that the dimension for the null space of A was 2 as well. But let's go ahead and look at a different matrix. And we're going to go ahead and look at problem 2A. And here we have A equals, oh, it's a big one. Make this larger. Okay, so we've got 1, 0, -2, 0, 0, -1, -1, 1, -2, -3, 1, 3, 1, 1, -1, 0. Oh my goodness. 0, 3, 3, -4. Okay, you might be faced with a matrix like this. So what do you need to notice if I'm going to ask you about the rank and nullity of this? What would you immediately be able to tell me? Without even solving this, even doing anything to it.
Oh,
You should be able to immediately assume something from that.
probably
Yes.
that nullity is one, potentially.
Actually, yeah.
Might not be, because it could all have like zeros on the bottom or something, but
Yep. You have a very good possibility that your nullity is one. Why?
it has one additional column.
It's got one additional column than,
A square matrix it would be.
so this is not a square matrix, unfortunately. What do we
Yeah.
have? We have a 4 by what?
4x5.
Yeah. So what is going to be the most that our rank could possibly be for this matrix? Yes, sir.
5,
What?
5.
No, 4.
So remember, your rank has to be common for
Yeah.
both your row space and your column space, right? So does everybody see why it would be 4? The most your rank could possibly be? Because at most you would have 4 rows with leading ones. That means your column space has to have that common rank, right? So it means the most, there's going to be 4 columns then with leading ones. So it's possible you might have a nullity then of 1, because then 5 minus 4 equals 1. Not saying that that's what would happen, but you have some things that, you know, if you get something different, you get more than a rank of 4, you know that you're off on something, right?
Is it
So-
at least one?
What now?
Is the nullity at least one here?
Yeah, so here it would have to be at least 1. So very good. So your assumption would be the nullity would be greater than or equal to 1. We don't know yet because we haven't really gone through it. All right, so I'm going to go ahead and give you cheat it and going to go ahead and give you, so here you would go ahead and do your reduced row echelon form. Let me check that online. They look like they're okay. Okay, so if I went ahead and did the reduced row echelon form, you would get something like 1, 0, 0, 0, and I go ahead and did it. And you get 0, 0. I encourage you to check and see if you get the same thing. 1, 0. So now, what would you say the rank of A is? I told you that that is the reduced row echelon form of this matrix. Sorry, this is a 0. Now, what would you tell me? Yes, sir.
The rank of A is 3
Okay, why is that?
because there's 3 leading ones.
Yeah, we look at leading ones. So we look at, so it looks like rows 1, 2, and 3 have a leading one. It looks like columns 1, 2, and 4. What then is our nullity of A?
2.
2. We are looking at our free variables. We also know that rank plus nullity equals n. That's number of columns. So we know that 3 plus 2 equals 5. All right. So just some things to note there. That could give you a lot of good hints about your system and ways to describe your system, even though you might not have gained all the answers. You have a very good idea of its properties. Okay, let's go ahead and we are going to now shift to our trivia. Are you all ready for your team trivia? So you will be doing this and coordinating with your team. So you will get your second chance for your bonus points toward your exam grades. Want to be the winning team. And I'm going to go ahead and share my screen here. So please make sure you have found this assignment in Canvas. So it's going to be your exam 3 review trivia. That means that each person will submit one of the problems. They're going to be the lead on submitting it. Did anybody have any questions about how this was run last time? You know that each person on the team needs to submit a problem answer. You need to show your work. Also, you need to make sure that you submit your problem answer as quickly as possible. Do not wait all the way until the end of class to submit them all, because based on your timing and who enters these answers the fastest and who also includes their bids, that's what helps me determine the winner. So for instance, if you're the fastest to submit a problem, you got the answer correct, you had a bid of $500, that's 500 points towards your score. So you want to make sure that you get that in there, and you want to give the highest bid to the problems you're most confident in. More sure that you got the correct answer. Any questions? Before we get started, are you guys ready?
What time,
Yes, sir.
what time does answer from
What now?
What time does it end? The
What
assignment?
time does what end?
The assignment. Whole quiz.
Yeah, we're gonna be done at the end of class. So you're gonna have about 7 minutes per question. Okay? So it'll close 2 minutes after class.
4.9, because I have not restudied.
Are you guys ready?
I think I got the beginning. I think I can do it.
Online, are you ready? So if one of your team members is missing, somebody else is gonna have to do that problem. Unfortunately, I will be posting who won the trivia later on this evening from last exam.
Honestly,
But I don't want it to discourage anybody knowing the winners. I want everybody to
also
compete for some points.
they choose the big.
Well, you will know
which person
next time. Okay, are we ready, folks? Right. I'm gonna set the timer. I will give you a 1-minute warning. You're gonna have approximately 7 minutes per question. So here we go. Here's your first question. I will post the answers afterwards like I did last time so you can study them.
Yes. Yes.
Good question. How do we submit it? Like, do we take picture and just send in the reply?
Yes, so you hit reply, and then you should be able to upload an attachment.
And just type out how much bid you want.
Yeah, and you want to make sure you include your bid. So in that text box, say, problem 1, bid 500, that's your image.
Like, do we do it right now or after?
Yep, you do it right now, yeah. So as soon as you're done, make sure you get it in.
Does everybody in the group need to do it, correct?
So one person per problem. So it looks like he's in charge of problem 1, so you go ahead and submit, and then the next team member will submit the next one.
Which was it? No. She can see the questions.
Yes, sir.
Do we write these, like, the amount we bid on the paper?
Yeah, you can write it on your paper, but it also is very helpful to write it in the text box
Yeah.
for replying, yeah. Make sure you just say problem 1, 500, or whatever your bid is.
It's the invoice.
Okay, please submit. Have your first team member submit. Your next team member should get ready for the next problem.
Sorry. I don't know why I shared with them. Check mark.
Team member number 1 should be submitting at this point. Team number 2 is on deck. Be ready to solve. All right, here is your problem number 2.
You can't solve it.
That's why I was like stuck. It's like he's like single. So it's always like, I should say no. It's such a funny thing. It's no. See, we have to just do it.
Are you back those out? Picture.
Switch it.
I didn't know, I don't know if I'm. We couldn't find the counters in the world, so I just came and
Show it like that. If they're, the two cannot be by each other.
yeah, because if I went home, they were all like separately in different places. We never did it. We just had them together in one. It's like-
Okay, that's enough. So I'll take this one.
400. easiest one though.
It might be the easiest one.
Do you think they have a better one?
Just 100, just 100. We have two.
All right, make sure you submit. That was problem 2. Sure you have submitted your bid along with it.
Four.
So that should be your team number 2. Team member number 2 is submitting problem 2. Make sure team member 3 is on deck to do the next problem. Are you ready? Here is problem 3.
It's not as really. Basic.
All right, make sure you submit your problem 3. So you should have 3 team members that have submitted. Your 4th team member should be ready to work on problem 4. Here we go. We are switching now.
Submit the last one.
I'm going to submit this. Yeah. Did you do 4 or 5 for yours? 400 or 500? Okay, definitely. How much money did you put on it?
I'll put 500. Did you check to see if it was legally independent and disbanded as well? Do there's 5 problems, so I can't submit them. But
All right, it's time to submit your problem number 4. Here is your last problem.
Be done in time.
Are you, so if you're still working on problem 4, you're gonna have to let the rest of your team do problem 5.
I wasn't working.
So problem 5 is appearing now.
For you to figure it out.
So have somebody submit problem 4 while the next person is working on problem 5.
Why do you have to? It's usually problem 5. We're doing the problem 5. Okay. What do I say is? Who's more confident? What if it's just all? I guess you just. That would be fine. You wouldn't feel okay? You have to do this last. Yeah, because each member has just something. I can reply at the reply to my. Yeah. So I can't.
All right, time is up for your problem 5. Please make sure to submit your work. And we have completed our trivia for exam 3. So make sure that you've got your work submitted. And if you are having some last issues with submissions, it is, let's see, I had it where you have a few extra minutes if you have any submission problems, you should be able to get it in. That will conclude. We'll see who gets their bonus points for that one. Okay. Thank you all for a wonderful semester. So I know you all will do great on exam 3 if you decide to take it. And I hope you enjoyed the fact that we had a lot of different things happening in this course. We had some videos that you had some flexibility with. We worked problems together. We've had a couple team challenges, and you also had a chance to work in your teams. So I hope that made the summer go by pretty quickly. And you are on your way. And promise me this, that you won't take any more summer classes, okay? Because guess what? You got to get what? What should you be doing in your next summer?
Internships.
Yes, internships. Please make sure you are. Yes, sir.
That's next week.
You have your exam 3 on Thursday, then the following Tuesday, you have your final chance to work in your teams to finish your project. Then next Thursday, we're watching your presentations.
Tuesday and Thursday will both be online.
Yeah.
So next Tuesday we do have, wait.
Yeah, so next Tuesday, you guys do not meet in here. You'll meet with your teams wherever you guys want to finish it up. If you want to meet in here, that's cool. Yeah, so Thursday, we get to see what you all came up with your presentations.
No, I did not.
No, you'll be online and we'll be watching and seeing what everybody came up with for videos.
I edit my response. I think it's an actual image, so you know.
Yeah.
But I didn't.
As long as I can see the chain of submissions, like this has the same and the problems.
Well, I submitted it before problem 3.
Yeah. So then the order of submissions is correct, right?
Reply chair.
Yeah. Oh, good job. Yes. Yeah. Reply to yourself. You're like.
I have to do that.
No, that's good. Is it better like that for?
As long as you think I can figure it out and you don't lose the chance for.
500. And it has the image, and you go to the image, and then see a 2. A little 2. You obviously know what a 2 is.
I mean,
I didn't put like problem 2. Let's do it.
oh, me neither. I just did like, forward next to it. But mine is fine because I have like all the way on the side. It's not just like a random number.
Thanks for the class.
Yeah, thank you so much. Thank you to those of you who participated in each class session. So I took note of who you all were. So a couple of you are repeats. So I appreciate it very much.
You and me were like the.
You were on it. Are you guys are on the same team too, aren't you?
Yeah.
Well, that was a
My
well-known
first
team.
day, I'm like, I gotta get the team.
You know, some stuff. I'll tell you what.
Look, you said, I don't.
Yeah.
I think I did good enough on the exam too.
I'm gonna take a.
I was worried because we're going through like intense problems. We're like 7 minutes left in the exam. I'm like, oh my God, what is happening? And then the last 3 problems were like, maybe not 3, like 2 or something. They were like really, really, really quick problems. You just had to know the formula and you could have just solved. And I'm like, oh, well, thank gosh, I
I
got
like that too. Yeah, that was way better.
I was like, I hope I'm not making a math error right now. It's like, super fast doing this.
No, like, we did, really.
I'm sure.
Like to get a sense on it.
Did ask. But she said.
Yeah, it's pretty low.
Oh.
I should be fine.
Yeah.
I need like a.
No excuse for people not passing this.
I mean, come on.
Looks like they can play that.
I need like a 60 or 70 on